Let's solve some more questions. Find the principal values of tan inverse minus under root 3 and tan inverse 1. You already know that in the principal value branch, the tan inverse function has got domain in the set of all real numbers, and its range in this interval is minus half pi to half pi. Now let's first find the value of tan inverse minus under root 3. Let tan inverse minus under root 3 be equal to theta, where theta is the angle which is greater than or equal to minus half pi and theta is less than or equal to half pi. Now theta is the angle the tangent of which is equal to minus under root 3. So we can write tan theta is equal to minus under root 3. And minus pi by 3 is the angle at which the tangent theta is equal to minus under root 3. So we can write tan theta is equal to tangent of minus pi upon 3. And now tan theta is equal to tan of minus pi upon 3, which means theta is equal to minus pi upon 3. And tan inverse minus under root 3 is equal to theta. So we can write tan inverse minus under root 3 is equal to minus pi upon 3. And this is the principal value of tan inverse minus under root 3. And now let's find the value of tan inverse 1. Again, let tan inverse 1 be equal to theta, where theta is the angle which in the principal branch is always greater than or equal to minus half pi and is less than or equal to half pi. Now tan inverse 1 is equal to theta, which means theta is the angle the tangent of which is equal to 1. Or in other words, tan theta is equal to 1. And remember from the values of trigonometric table, tangent of 45 degrees is equal to 1. So in place of 1 we can write tangent of pi upon 4. Or that means tan theta is equal to tangent of pi upon 4. And that means theta is equal to pi upon 4. And now tan inverse 1 is equal to theta. So we can write tan inverse 1 is equal to pi upon 4. And this is the principal value of tan inverse 1. Now let's solve one more question. Find the principal values of cosecant inverse under root 2 and cosecant inverse 2. Now you already know in the principal value branch, the cos inverse function has a domain of the set of all real numbers except at minus 1 and 1, and its range is from minus half pi to 0 and from 0 to half pi. And now to find the value of cosecant inverse under root 2, let cosecant inverse under root 2 be equal to theta, where theta is defined from minus half pi to 0 and from 0 to half pi. Now cosecant inverse under root 2 is equal to theta, which means theta is the angle the cosecant of which is equal to under root 2, or we can write cosecant theta is equal to under root 2. And what is the angle for which cosecant is equal to under root 2? That angle is pi upon 4. So we can write cosecant theta is equal to cosecant of pi upon 4, and that means theta is equal to pi upon 4. But cosecant inverse under root 2 is equal to theta. So we can write cosecant inverse under root 2 is equal to pi upon 4, and that is the principal value of the cosecant inverse under root 2. And now we shall find the principal values of cosecant inverse 2. Again, let cosecant inverse 2 be equal to theta, where theta is the angle which is defined from minus half pi to 0 and from 0 to half pi. Now theta is the angle the cosecant of which is equal to 2, or we can write cosecant theta is equal to 2. And from the trigonometric tables, you know it very well that if cosecant theta is equal to 2, then that means the angle is 30 degree or pi upon 6. So we can write cosecant theta is equal to cosecant of pi upon 6. And from this equation, it is quite clear theta is equal to pi upon 6. But cosecant inverse 2 is equal to theta. So we can write cosecant inverse 2 is equal to pi upon 6. And this is the principal value of cosecant inverse 2.